So the next part of this projectile motion problem is to answers D and E. It's a problem we haven't actually taken a look at for a while, so it's going to kind of change the gears up, but we'll just do a little bit of review. And so we've already answered the max and min questions. We have a parabola. We know this ball is going up and it's coming down and it's reaching its apex. So I think we got 11/4 at 127 feet. So that's what B and C were all about, and then at 1 second we figured out that we were so high. But the next question asked us is, when's the ball going to strike the ground? So for striking the ground, that essentially means that my height above the ground is 0. So we basically have S of t, or h of t, equals to 0. And so we're essentially looking for the x-intercepts, right? Where does this cross the x-axis? So we know how to do that. We'll set the equation equal to 0. Okay, and we'll have to pull out of our little toolbox how to solve a quadratic, because that's what we have here. The easiest way to solve one is to probably factor, but I don't think this is going to factor very well at all, just because 6 times 16 isn't anywhere close to 88. And so getting things to add up to 88 and multiply up to that is going to be impossible. Completing the square is not a lot of fun, right? Because just dividing by 16, we get a nice fraction and ugly numbers. So really, our best bet here is to use the quadratic formula. And before I do that, how about, notice everything has a 2 in it, so I'll divide it by 2, and we basically get negative 8t squared plus 44t plus 3 is equal to 0. So I would much rather work with this A, B, and C. It's already kind of a big number than these A, B's, and C's. So let's work with that. So we have negative 44 plus or minus, right, the square root of 44 squared minus a 4 times an A times a C, all divided by 2 times A. Alright, and so now we clean this up. We get negative 44 plus or minus, and here's where we're going to start busting out this calculator. I believe we have a minus of a negative, so that's a plus, and then 4 times 8 is 32, times 3, that's a 96, so that I can do in my head. But 44 squared, let's bust out the calculator, right? So 44 squared gives us 1936. This is all divided by negative 16. And so 1936 plus 96, right, equals that. And I don't know if that's a nice, neat square root, so we'll just keep that. So we have t is negative 44 plus or minus the square root of 2032 all divided by 16. So we'd have two potential, which doesn't surprise, right? Parabola would have 2 intercepts. So these are the 2 intercepts that we're going to be considering. And so now we'll turn to our calculator to kind of get an estimate of where these are at, right? So estimate. So again, busting out the calculator, I'm going to put the top in parentheses. We've got negative 44, and then we're going to add the square root of 2032. Oops, wrong way. Close those parentheses and then divide this by negative 16. Alright, and what I end up getting is a negative 0.067, let's call that 36. So that's this intercept on the back end. Now this intercept actually doesn't make sense because when time equals to 0, we are already 6 feet above the ground. So we're not going to go back in time to see when we reach the ground. So it's really that time value that we're interested in, and that's probably going to be this guy here. So nice trick to your calculator. Rather than retyping all that, if you press second and then the enter key, it basically puts that entry that I last did, because the only thing that's changing is that plus is changing to a minus. So I'll just scroll over, change that to the subtraction statement, and we get the time value of 5674. So the ball is going to return to the ground at 5.5674 seconds. So we already know that it's going to reach its maximum height at t equals 11/4, or what we said is 2 3/4 seconds, and then its maximum height is 127, and then if we keep our timer going on to almost 5.5 seconds longer, that's when we expect the ball to hit the ground. All right, so we haven't solved a quadratic in a while, so I think there's some homework problems like that, and good review of some past material, even though we've been so focused on the vertex. Thought it'd be a good way to go back to that. Part E, we want to know at what time does the ball reach a height of 40. So we're not hitting the ground, we're not at a high point, we're somewhere in between. And just visually, right, if this is 40, we can actually see that there's twice when the ball hits 40 feet above the ground, right? One when it's going up, hits a high point, and then one when it's coming down. So we expect two values, and again, this time our h of t is equal to 40. So we set our equation equal to 40, and a way to solve a quadratic is to kick things around. And how about I do this? I'm going to divide everything by 2 first, and we get negative 8t squared plus 44t plus 3 equals 20. And if I subtract 20 from both sides, we get negative 8t squared plus 44t, that's a minus 17 equals 0. So I'm pretty confident that that's not going to factor very well. So utilizing the quadratic formula again, we have negative 44 plus or minus 44 squared minus a 4 times an a times a c, and then all divided by negative 16. So we definitely are going to probably be using our calculator at this point. So I think this, we know 44 squared earlier we found is 1936. We're subtracting a negative, subtracting another negative, so we'll be subtracting there. And it looks like, let's see, we get 4 times 8 times 17. That's a 544. So t is negative 44 plus or minus, if I take 1936 and subtract 544, we end up with the square root of 1392 all over negative 16. And so again, there's two values here, one with the plus and one with the minus. So let me do the plus first. So we get parentheses negative 44, and then we're going to add the square root of 13, what did I write there? 1392, it's right above me. Close my parentheses, divide by a negative 16, and we get a value of 0.418, how about we say 2 seconds. So that's probably this time value right there. So within a half second, we've already reached 40 feet. What's this other time value when we come down? So again, just that little trick, second and enter. It brings up that last input line, and all I need to do is change that plus to a minus, and we end up getting 5.08 is the other one. So 5.0818 seconds. So there we go. We've totally analyzed this graph. So we know what time it reaches its high point. We know what that high point is. We know when it strikes the ground, and we know when it hits 40 feet above the ground, both going up and downwards. So good review of solving some quadratic equations, along with our new stuff of maximizing and optimizing a projectile motion problem. All right, so that should wrap that up. We're going to be doing some regression analysis and breaking those calculators out again to wrap up this section, and I'll talk to you guys then.